The ferromagnetic core has mean path length of 40 centimeters. There is a small air gap of 0.05 centimeters as shown in figure. The cross-sectional area of core is 12 centimeters square. Relative permeability is 4000 and number of turns is n is equal to 400. Assume that fringing in air gap increases the effective cross-section by 5%. Find the total reluctance and the current required to produce flux density of 0.5 Tesla in the air gap. So like always, we will first write down the information that is given and also what we have to find out. Okay. So what is given here? The mean path length is given as 40 centimeters. Right. That means this is the flux path. Right. This will be the flux path. See, I will draw here. The current is flowing in this direction. So the flux direction will be like this. Okay. So what is the length of the flux path? This entire length, and that is the mean path length, that is given as 40 centimeters. Okay. Next, this air gap width, it is given as 0.5 centimeters. So we will take that as Lg is equal to 0.05 centimeters. Okay. And the cross sectional area of core, that is 12 centimeters square. And the relative permeability, that means mu r is equal to 4000 and number of turns is 400. Okay. So now we will take this to be the core area, and the air gap area, this is going to be increasing by 5%. That means 12 centimeters square plus 5% of 12 centimeters square. That will be the effective area at the air gap. Okay. Now what we have to find? First we have to find the reluctance. Now what is the expression for reluctance? This is given by L by mu A. Okay. But here we have the core as well as the air gap. Okay. So now you can see that the same flux will go through the core, same flux will go through the air gap. Okay. So the reluctance of this air gap and the reluctance of this magnetic core, they will both be in series. Okay. So R effective is going to be the reluctance of core plus the reluctance of the air gap. Okay. So now what will be the reluctance of the core? This will be the mean path length divided by mu naught into mu r, which is given as 4000, into area of cross section is AC. Okay. So here we know LC, which is 40 centimeters, mu r is given, mu naught is 4 pi into 10 to the power minus 7, and AC is also given 12 centimeter square. So you convert everything to meter, then it will be better. Okay. And what about RG? Here the air gap length Lg divided by mu naught. There will be mu r is simply equal to 1 for air. Okay. So you can write 1 into area of cross section of air gap. So Ag also we know. So we can substitute these values here. 40 centimeters. So 40 into 10 to the power minus 2 divided by 4 pi into 10 to the power minus 7 into 4000 into 12 into 10 to the power minus 4, because it is centimeter square. Okay. And here this is going to be Lg is given as 0.05 centimeters. So 0.05 into 10 to the power minus 2 divided by 4 pi into 10 to the power minus 7 into 1 into finally the Ag you can write as 1.05 times 12 centimeter square. Okay. So this value you are going to get if you calculate 66,314.55. The units will be ampere turns per Weber, because reluctance is the mmf by flux. Okay. And this value you are going to get 315,783.61 ampere turn per Weber. So now the total reluctance, this is going to be the addition of both these. So finally you are going to get 382,098.16 ampere turn per Weber. Okay, so this is the first part of the question. What is the second part that we need? We want the current that is required to produce flux density of 0.5 Tesla. Okay, So this is we just have to apply the equation. mmf is equal to the effective reluctance into the flux. Okay. So this you can write as N times I is equal to, we know the equivalent reluctance. Now phi you can either write as phi is equal to the flux density in the air gap into the area of cross section of the air gap, or you can write the flux density present in the core into the area of cross section of the core. But in the question what is given, you have to see, right? Flux density of 0.5 Tesla in air gap. So area of cross section also we will take the air gap. Okay, so here phi is written as Bg into Ag. Okay, so N is anyways known, it is 400 tons. I we have to find out. Reluctance we got as 382,098.16 into flux density in the air gap is 0.5 and area of cross section of air gap, it is 1.05 times 12 centimeter square. So if you calculate this, the current you are going to get as 0.6018 amperes. Okay. So this is the current that is required to set up a air gap flux density of 0.5 Tesla.